especially thanks to the Faculty of Civil Engineering in Belgrade for helping organize this session, with SUZI, with our Association for Earthquake Engineering, and with European Facility for Earthquake Hazard and Risk. So my talk is intended to give an introduction to the workshop, and I will address the notions, the issues of hazard and risk and resilience. And what I will try to do is to ask questions and provide some answers, and to point a little bit of how I think we should go forward. So let's start. The first question that people ask very often in countries of fairly low seismic exposure is, do we have an earthquake problem? And the first answer is, well, no, it never happens. And so here is what it means that it never happens. This is an EFEHR animation, and this is approximately where my lifetime starts. And so after 1962, there has been quite a few earthquakes. And even after 2000, there has been enough earthquakes to pay attention. So this first answer doesn't really make a lot of sense. The second is like, okay, fine, we have earthquakes, but in small earthquakes that may happen, we will have no damage. And we don't even have to have too much earthquake insurance, but that doesn't happen either. And so these are, again, goes against the common wisdom in low and moderate seismic regions that earthquakes don't happen. And even in regions of high seismicity, there is a confidence that after so much 50, 60, 70 years of earthquake engineering, we can design earthquakes very well, that even if they happen, they will be handled in some sense. The damage will be negligible, we will repair it quickly, and the society will not be affected. And here is a picture from Chile, where we had quite a lot of interruptions because of a few collapsed and many damaged tall buildings. And ultimately, it comes to Christchurch, where we had a major societal disruption. Yes, the earthquakes and the aftershocks lasted for a couple of years, but we had a problem there that is still somehow being solved. So yes, definitely we have an earthquake problem, even in regions of fairly small seismic hazard like Switzerland here. And Serbia, we don't consider us to be a very seismically prone region, but we're still fairly red. And in that sense, it is definitely worth looking at seismic hazard by itself. So before I move on, there is one question that we often ask in our profession in earthquake engineering, and that is, how do we tell people about seismic hazard? And these are the formulas that we often use for our mathematical approach to seismic hazard quantification. Annual rate of exceedance, the return period. We use a Gutenberg-Richter law, a power law to describe the probability of recurrence of an earthquakes. And we often refer to in seismic codes to the exceedance probability of a threshold in a 50-year period. That seems to be something like a lifetime of an earthquake. And in that sense, there is probably a good way to tell non-engineers what we are really aiming for. In a life cycle of a building where we start with some kind of conceptual design and analysis and fabrication and construction and all the stuff that goes on, the use of the building, we may happen to have an earthquake. And if that earthquake interrupts the life cycle of the structure, that would be a situation where we would like to be protected from, and we somehow want to avoid shortening the life cycle of the earthquake prematurely. That's the life cycle of the building prematurely. And so given some earthquake hazard, where do we go next? What do we do? And in the practice of earthquake engineering, we look at the impact. We look at the impact of the earthquake. And here we focus on, I will address two parts of this impact. One is the individual structures, and then later on I will move on to communities and see how we may want to address communities in that sense. So let's take a look at an individual structure. What could possibly happen? First, structures do get damaged in an earthquake, and they may even possibly collapse. The Solihull Hospital barely made it out, but this is a collapse after an earthquake is a common, unfortunately, too common of an occurrence. And so they get affected. And the way that we calculate this, the way that we look at this in an engineering sense, in the mathematical models, is by formulating conditional probability curves that express our estimates of how likely certain fragilities, how likely certain damage states of a structure are. Let me just mute Zoran because I can at least hear him. Just a second. So let's go back. And so we will, the fragilities and the damage are what we are going to describe mathematically. We also want to be able to look at the losses. And the losses come in two different species. There are direct losses to the property itself that are quantifiable, and indirect losses to the business and the function of the building that are also quantifiable. We also have losses to the society and the services that our buildings provide. These are not so easy to quantify, but we do want to take them into account when we look at communities. So mathematically, when we go backward and we want to compute the losses, we can do this by integrating the hazard probabilities, the hazard curve, and our estimates of damage and fragilities and losses to obtain what we know as loss curves that express the annual rates of return of a certain monetary equivalent of a loss. So together, there is a framework, a mathematical framework that was developed by the Pacific Earthquake Engineering Research Center that implements the total probability to compute the loss in several different stages. It is known as the PEER framework for performance-based earthquake engineering, and we find it quite useful to work in this because there is a place for seismologists, there is a place for EFEHR, there is a place for structural analysis and damage analysis, there is a place for exposure, there is also a place for loss analysis. There is a place for pretty much everything that we will cover in this workshop. And I will go a little bit through all of these questions. As you know, Laurentiu is going to talk about the hazards. Helen, to some extent, is going to talk about the exposure. Vesna is going to talk about loss analysis for individual buildings. Key to understanding how they behave in the world or Europe or in Serbia is the taxonomy of structures. It is an attempt to group structures into common families, into families that have quite a lot in common. And here, Svetlana's work and the work of the World Housing Encyclopedia is the beginning of classification of buildings into useful categories for assessment of seismic risk. And the next step of this is the taxonomy and the typology that was developed within the European framework that is used quite widely today to classify buildings. And when Helen starts to talk about this, she will definitely, I'm reasonably sure that she will address these aspects of exposure. We do have risk, damage happens. So what happens after damage? We do earthquake, post-earthquake repair. We mitigate the structural damage explicitly by repairing. And here is a picture from L'Aquila 10 years after the earthquake, where a long lasting effort finally succeeded in bringing back the old town to close to its previous self. Not to be underestimated is the functional restoration. This is a school in Nepal that was newly constructed, but it is important to emphasize that these kids did not have a school after an earthquake, and this is a very important aspect of post-earthquake activities. We can do a couple of other things after an earthquake. Immediately after an earthquake, we can do rapid loss estimation, and this is the work that is done by my brother Zoran, who is also in the audience, and a couple of colleagues there at the University of Belgrade to develop a framework for such rapid loss estimation. Of course, it's not the only one, but it's there, and you can also ask about this. Then there is another framework developed by Vesna, who is also in the audience and also a graduate of the university of our faculty, for functional recovery estimation. And this is something that she will explain. It has a number of steps, and it is complicated because the buildings themselves have a huge number of facilities that enable their function. And the more complex the function of the building is, for example, hospital, the more complicated its network gets. And finally, one very important thing that we have to do after an earthquake, and in some sense in expectation of the next one, is seismic retrofitting. And this is a continuous effort which we have to support with our expertise, but also our governments, our communities, our responsible people, stakeholders have to support these efforts to eliminate vulnerable buildings from the communities so that they can move on faster after an earthquake. And here is where I come to communities and structures. So a single building that I talked about, a single fragility curve, a single vulnerability curve, a single seismic hazard at location, a single type of exposure, a singular loss. This doesn't tell the whole story. This one building is a part of a much larger community. And here is an example from Christchurch. This is the city, and this is a small block that represents very nicely the diversity of damage that happened there and its distribution. So buildings alone definitely do not make up a community, and addressing the consequences of the earthquake series in Christchurch involves addressing all of those buildings, even the ones that are green, but may need to have their functions restored. So when it comes to assessing what earthquakes do, I think that individual buildings are good to know, but it is really at the community level where a major effort needs to be invested, and it is there where we see the consequences of the earthquake. It is also there how the society judges if the earthquake was a strong one or a moderate one or didn't make a big difference. It is in the societal functions. So we have to take a look at that, and the individual buildings and the individual building hazard that Lorenzo is going to talk about is the beginning, but there is a complication. There are a few that he will address on the regional level, but one of them that comes to my mind first is the correlation between the seismic intensity fields. There is also further correlations in the types of buildings. And here are essentially identical buildings from Niigata, a very well known old picture where some survived, some didn't. And this had to do with the soil condition there. But it is the types of buildings that are very important, that form the basis for an exposure analysis that Helen will talk about. And here is a report from Joint Research Center of the European Union on seismic fragility curves for European building stock that are categorized by different types of buildings following a typology that was developed on the basis based on this World Housing Encyclopedia and this genetic-like structure of building characteristics. The buildings, even though they may be in the same type, differ. They differ because they're aging differently. There may have been remodeling in ones and not in the others. They differ in the function that they provide to the society. So it's not all covered by a single type. And definitely what is not covered by looking at the buildings is the role of infrastructure systems. And here is an attempt to illustrate how housing is dependent on other transportation, on other infrastructure systems in our community. And the conceptual view of this just emphasizes that there are services provided by the infrastructure to each of the buildings, here at least 4, without which these buildings have a hard time functioning. And here is another example. This is the Shelby County example from Tennessee that has been analyzed greatly because it shows plastically the electric power system, the water distribution system, the natural gas system, and all of them together on top of the roads. And so what is characteristic of the infrastructure systems are the interdependencies and the dependencies. And this is something that Nicola will address in his talk. And so all these things come together. They come together on a big map. They come together in the map of the communities where we study collectively the exposure of the society to a potential earthquake in terms of the residential building structures, in terms of the commercial building structures. And that is how we attempt to formulate the notion of seismic risk, earthquake risk at a community level. And here is a map of the estimates of seismic risk at the European level from EFEHR. And if you may recall the map of seismic hazard, it wasn't all that red here. And this is where the Basel is in Switzerland and Freiburg is in Germany. And this is a fault in the making in the middle of Europe that caused a few larger earthquakes in the past 2,000 years. And by itself, they were not large, but the housing, the inventory, the exposure in that area is critical because it simply was not designed with any earthquakes in mind. And that is what makes a difference. That is what often makes a difference. And here is what we can ask ourselves today. What can we do to manage and address and somehow contain and understand the current earthquake risk? And there are several things. There are early warning systems, and this is current work in our RISE project, just finishing a European project called RISE that is just finishing, whose goal was to formulate a facility for dynamic risk assessment, starting from a large number of sensors gathering very early data that would provide early damage estimates to going even towards estimates of recovery. In that sense, we are very concerned with the notion of resilience. And here is the iconic graph that stems from the MCR study of Michel Bruno and colleagues in Buffalo and elsewhere where the MCR Center was located, that summarize graphically in this swoosh-like curve how after the event there are losses that are being mitigated and recovered after a while, and the community itself or the building, but let's say the community is what we're focusing on, can recover and does recover. And we are very interested in how deep the losses are, how quick the recovery is, and what the endpoints of that recovery are. Studying this is possible now. It is possible through frameworks that look at the behavior of communities, that look at the recovery process itself, and try to portray it in terms of a Gantt chart to look at factors that impede recovery, to look at various interdependencies. And this IRECODES framework is what Nicola is going to be telling you about. This is his current doctoral research. Finally, we can do one very, very important thing, and that is to show the stakeholders, policymakers in our communities that they can affect the community risk by introducing public policy documents, ordinances, laws that guide immediate actions on vulnerable buildings. And this is one of, I think, the first one that was introduced in San Francisco that addressed unreinforced masonry buildings that over some 30 years were repaired or demolished and replaced with safer buildings. These kinds of actions is what a community can do to address seismic risk, and over time, they are very effective. For us engineers, we know that we support the communities. We play a vital role in engineering the resilience of communities. Engineering their resilience means understanding the hazard. That's why Lorenzo is there. Understanding the risk and exposure. That's why Helen is there. Understanding the recovery process, the functional recovery. That's what Vesna will talk about, and the recovery of communities. So we support this engineering, resilience engineering, and we have to make our role known to policymakers. One thing coming from Singapore, from our Singapore ETH Center and our Future Resilient Systems project, is our mission statement. It is the fact that the future is going to be clean and green and healthy. And really, there are no alternatives. With climate change, we probably already know that it's happening, that we've got to do something. Cleaning up the waste is also a priority. And of course, health, not only in terms of human health, but also in terms of the health of communities. And so what do we do? What do we do next? What can we do in terms of this problem? We have to, my belief is that we can orient ourselves around two directions. Using sustainability and climate change mitigation that are already there, that are driving the urban systems change today, I think it's worth going along that path, that powerful train, and combining seismic retrofitting and rehabilitation and seismic design together with thermal and carbon reduction design to produce jointly optimal solutions. And there are a few projects at the European level, and here is the final report from one. And the second thing that we ought to do as civil engineers working in our communities is to continuously monitor and review resilience of those communities, to look at how the hazard is changing, how the risk is changing. We build new buildings every day and change the old ones, so the risk is changing, to attempt to engineer some resilient features into new buildings, to attempt to retrofit old buildings with better capabilities, and to use proactive public policies to increase resilience, to work within this cycle of resilience, and over time make sure that the next generations inherit a better, safer, cleaner, greener, and healthier community. So with that, I want to thank you for your attention. And I don't know if there is any questions now or later, but for sure you can find me on the web and send an email if you have questions, and I'll be happy to discuss them with you.
Thank you, Boža, for a very excellent presentation and giving a big picture overview of the whole workshop and the topics that various presenters will be talking about in more details. I'm not sure if you heard an applause, but I'm sorry that we cannot that you cannot see us. So given that Professor Stojadinović is not going to be with us, for this is his only appearance at this workshop, I would invite any questions at this point, and I believe we will also have a few minutes for questions after the following presentations. So any questions for Professor Stojadinović? Maybe you can say, and I'll tell him because he cannot hear. We are in the Svečana Sala, so you cannot
Okay.
Yes. So any questions or comments that you would like to make, please go ahead. Actually, okay, I don't think we have any questions from participants. So I would like to ask you, I would like to ask you one question. Do you have any advice, since we are really at the beginning of that path here in Serbia? What is the way to go? What is the way to encourage? I said at the beginning of this as an opening comment that one way is to organize events like this, but what do you see as a way of making a progress and understanding better both the risk and consequences of course, earthquakes, as you discussed?
The way forward starts with workshops like this. There has been quite a lot of really good work going on at a few centers of excellence in Europe. The GEN project, the OpenQuake project, the EFEHR people, several large European projects also. And the amount of knowledge that has been accumulated, the amount of decision-making tools that have been developed, is now critical in some sense. It is ready to be transferred to practice in many ways, and definitely ready to be transferred research-wise to other parts of Europe that have not had the luck to be involved in those proposals, the opportunities to work there where the knowledge was made. And now the workshops like this are excellent opportunities for everybody to catch up, to get to the same level, and to move the ball forward as it may be, towards first of all understanding the hazard locally better. Second, my opinion is that exposure needs much more work to be sharpened, to be better described than what we do currently. And finally, the work on recovery. The things that you will hear from Nicola and Vesna point to how we may address that important problem, because after damage there comes recovery. It is a crucial activity that makes communities resilient, and that needs to be followed up through. So I welcome the organization of these workshops. I welcome the hands-on sessions, and definitely hope that there will be people interested in taking part and doing their part locally on hazard risk and resilience, and hopefully also being able to join European efforts.
Thank you very much. I'll stop recording right now.